Welcome, everyone. Let's dive into the use of properties of exponents and explore how they can help us in mathematical calculations. The properties of exponents are powerful tools that make it easier to simplify polynomial or monomial expressions and solve equations with exponential terms. To begin, let's clarify the key terms that are fundamental to understanding expressions, monomials, and polynomials. A monomial is an algebraic expression that consists of a single term. This term could be a constant, a variable, or a combination of both. For example, 7 is a constant monomial. 3x is a monomial involving a variable. In contrast, a polynomial consists of one or more terms that are added or subtracted together. Each term may involve constants, variables, or their products. For instance, 2x power to 3x1 is a polynomial with 3 terms. By using the properties of exponents effectively, we can simplify these expressions to their most concise forms. Before simplifying expressions, we must ensure that the final result meets the following important conditions. First, there should be no powers of powers. Second, each base should appear exactly once. Third, all fractions should be in simplest forms. Finally, there should be no negative exponents. These conditions ensure that our expressions are not only correct, but also as clear and simplified as possible. Let's move on to an example of simplifying expressions by multiplying simply form of monomials, 3x power to multiply for x power 3. First, multiply the coefficients 3 and 4. This will result in 12. Next, multiply the variables. When multiplying terms with the same base, we add their exponents. Therefore, x power 2 times x power 3 will be calculated as x power, which is x power 5. Finally, combine everything. The simplified result is 12x power 5. This demonstrates how straightforward it can be to handle monomial multiplication when we apply the properties of exponents step by step. Let's tackle another example to reinforce the concept. First, multiply the coefficients 2 and 3, which is 6. Next, simplify the terms with a by using the product property. Then a power negative 2 times a power 3 will calculated as a power negative 2 plus 3, which is a. The terms with b remain unchanged, b power 2. Third, simplify the terms with c. A negative exponent indicates reciprocal, so c power negative 2 will be equals to 1 over c power 2. Lastly, combine everything. The simplified expression becomes 6a power 2 over c power 2. Next, let's look at dividing a polynomial by a monomial. Here's the simply example, 8x power 4 minus 12x power 3, divided by 4x power 2. First, split the numerator into separate fractions. Next, simplify the coefficients for the first term, 8 divided by 4 equals 2, and for the second term, 12 divided 4 equals 3. Third, simplify the exponents using subtraction. For x power 4 over x power 2, subtract the exponents. This results in 2. So it becomes x power 2. For x power 3 over x power 2, subtract the exponents. This results in 1, so it becomes x. Lastly, combine the simplified terms. By breaking the expression into smaller, manageable steps, division becomes much simpler to handle. Here's another example that involves a bit more complexity. First, simplify the monomial 3xi power negative 1. This results in 1 over 3xi. Next, rewrite the expression by separating polynomials to monomials. Third, simplify each term. For 18x power to y over 3xi, divide the coefficients, which results in 6. Then, simplify the variables x power to y over xi, which is x overall. This gives 6x. Also for 27x power 3y power 2z over 3xi, calculate the coefficients and simplify the variables. Then the calculate is done. Finally, combine the simplified terms. The final result is 6x 9x power to ease. That brings us to the end of this presentation on simplifying expressions using properties of exponents. I hope these examples and explanations have clarified the process for you. Thank you for watching this video.